protecting public health. So, eliminating toxic substances is a great way to continue that tradition and trend.
And you mentioned that cost drives it as a decision factor. So if you're a district manager, town planner, what should you be thinking about in regards to this?
When I talk, folks call me all the time and say, "Hey, I want to put a mixer in my tank. What kind of mixer do I need?" And really, the first question I always ask is, "Well, what's your process goal? Why do you want to mix your tank?" Thermal stratification is a really common issue in most tanks where it's hot out.
The board of directors said, "Oh, it's definitely the manganese removal system that's jacking up our pipes."
Yeah, sure.
What have you learned through your experience? A lot of one of the bigger complaints is like how stagnant the water has gotten, or the tank mixer continually goes out. When you're picking a tank mixer, what are some main points that if an operator's replacing one, they should be looking at? So you got a lot of contract operators that are running 10 systems, and they're getting phone calls when there's actually a problem instead of an alert, a page even. Thanks for coming on the show today. I've got Ethan here with Clean Water One. Thanks for coming on.
Hey, great to be here, Mike.
I kind of wanted to first talk about a lot of rural communities have issues with like their SCADA monitoring and adequately having things kind of downstream adjust as their kind of intake water changes. What do you kind of see?
Yeah, sure. Setting up automated processes with SCADA is really handy if you've got it. But for small systems, sometimes maintaining SCADA can be a challenge. The programming that goes into SCADA is expensive, and there's a lot of folks that I talk to that don't even have SCADA at all. But these days, with communication devices being ubiquitous, we've got phones in our pockets always, right? There are interesting opportunities to, do SCADA Lite. So essentially, have your equipment, send information up to the cloud that you can then get straight onto your phone. One of the things that we do around that is with some of our tank-based treatment processes. We do a lot of work in the distribution system to deal with things like elevated disinfection byproducts or low residual. And these are remote assets that are kind of maybe far away from the plant. And so we've had a lot of success kind of implementing cellular-based modems where we can get information, pass it up to the cloud, and have it come back onto your phone. So you've got real-time visibility about what's going on out in the distribution system.
And even you're talking about the monitoring can be as simple as just getting some basic alerts. Yeah. You got a lot of contract operators that are running 10 systems, and they're getting phone calls when there's actually a problem instead of an alert, a page even.
Sure, yeah. No, it's a real challenge, and just got to maintaining information about the quality of your equipment that's remote. It's important. Alarms can be important, but also understanding, what's the water quality like in my tank. Having some visibility of residual levels, having some visibility of something as simple as water levels in the tank. If you can get that again in your pocket on your phone, that can be really helpful.
Yeah, knowing like if you've got a system that the tank's running all the pressure on, and you see that you're, instead of someone saying they had water pressure, if you see the tank drop to 2 feet left, like you're already gonna know.
Yeah, exactly. It's nice to have an alarm for something like that that's on you. Yeah.
Cool. All right, my next question was about like storing hazardous materials on site and the cost of chlorine addition. How do you guys kind of think about that?
So one of our most popular products right now is the on-site hypochlorite generation system called the Micro Chlor. And the reason that the Micro Chlor is popular is all about safety and the cost of goods. The price of hypochlorite has more than tripled since the beginning of the pandemic on average. And we can make our own hypo essentially using electrochlorination. So Micro Chlor is set up so that you don't have to store any hazardous material. You just store salt, and then we use salt, water, and electricity, put those things together in the right way to make our own low strength hypochlorite. On-site generation is really a technology that's been around for a long time, but it's gaining a lot of popularity. And again, that's partially driven by cost, but it's also driven by safety. The product that we make is 0.8%, so it's 15 times more dilute than the 12.5% bulk hypochlorite that a lot of folks are using. And at that low concentration, it's no longer considered a toxic substance. So if you spill it, you get a mop. It's not a reportable event. You don't have to use secondary containment. It's easy to transport, so you can put it in the back of a truck and drive it around. And particularly for small systems, it can just give folks some peace of mind that they've got, a much more friendly substance on hand rather than something that's toxic that you really have to worry about. For example, well sites. Wells are oftentimes in the middle of a community or the middle of a residential area. And, if you've got chlorine gas cylinders in the middle of a, big suburb, that's not a very ideal setup. That's a, weapon of mass destruction. And so,
essentially, it can explode.
If the gas gets out, it kills everything. I mean, it kills everything. It kills the bugs. It kills. It's mustard gas, right? So, don't want that getting out and escaping.
Not at all.
Yeah. So, on-site generation system can be a great solution for a situation like that.
Like kind of going back to that kind of time-constrained operator in a smaller community, if you do have a problem, it's nice not to have to go back and have to report the whole thing.
Absolutely. Yeah. And safety first, right? I mean, everything we do is about protecting public health. So, eliminating toxic substances is a great way to continue that tradition and trend.
And you mentioned that cost drives it as a decision factor. So if you're a district manager, town planner, what should you be thinking about in regards to this?
When I talk to a town manager about on-site generation, one of the first things I want to do is sit down and understand how much they're spending on hypochlorite, and then comparing that to how much they might spend on the consumables to make their own hypo. And, if we could see a 4 or 5 year payback, that's an easy decision to make. And that happens with great regularity.
In terms of water wastewater, 4 or 5 years, pretty quick. It's not like investing where it needs to happen a lot faster.
That's right. Yeah. If you can pay for the capital spend in 4 or 5 years and then start putting money back in your pocket, that tends to keep the bean counters pretty happy.
Cool. In the distribution system, so here's during our survey, one of the things that came up was there was a lot of black sediment in these pipes.
Sure.
At least from the board of directors said, it's definitely the manganese removal system that's jacking up our pipes.
Yeah, sure.
What have you learned through your experience about what really causes? Do you know what I'm talking about? It kind of looks almost like shale in the pipe, or it's like
manganese precipitation.
Yeah.
So the challenge is, manganese is present in lots of groundwater. So many folks who are running wells have got manganese in their water. And manganese will come out of solution and precipitate out in the presence of chlorine. So if you've got a chlorinated well system, it's pretty likely that you're going to have some manganese coming out of solution. I live in California, where the state is planning to implement new regulations to limit the amount of manganese that's allowed in the pipes. And so this is definitely going to be an increasing challenge for folks. And the reality is, we don't have a great solution for this. When manganese comes out and precipitates out, it can definitely leave that black sediment that you were describing behind in the pipes. And so really the thing to do there is to flush your pipes and implement a really good flushing program. And I'll put in a little plug for flushing. The California-Nevada AWWA Distribution System Water Quality Committee just released a really good manual on implementing flushing programs. And so that's something that you can find on the AWWA website.
To quickly summarize, have you read it? Or could you quickly summarize some of those high points? Because I find it hard to even get the operators to get on a flushing program because they're so strapped on the production side sometimes. And so maybe you can highlight it a little bit why they should be doing it.
So flushing your system is going to help get any sediment that's kind of come out as settled out or precipitated out of your system. And it can be challenging to figure out how to do it because you're basically going to crank open some hydrants, get a lot of flow through your pipes, but you can mobilize sediment as well if you're not doing it carefully. So the manual I'm describing will really help folks, kind of look at what would a flushing program look like for us? What are some of the things we need to think about? How do we institute unidirectional flushing so that we're moving the sediment in the right way, not to create more problems than we're solving?
Oh, that's a great point. So unidirectional meaning shut valves off on trunk lines.
Exactly.
Only have the water coming from the plant directly to, or more just kind of very
And in some distribution systems, when you look at the layout, it's very obvious how this should go. In other systems, it's a little more tricky to figure out. So the manual could be a really good resource to help folks kind of get a sense for what it might look like, especially if they really haven't thought about doing a flushing program before.
Gotcha. All right, one more question about tank mixing.
Sure.
A lot of one of the bigger complaints is like how stagnant the water has gotten, or the tank mixer continually goes out. When you're picking a tank mixer, what are some main points that if an operator's replacing one, they should be looking at?
So tank mixing is recommended for every tank, right? So AWWA standards are put a mixer in every tank. But from our research, only about 10% of tanks actually have a mixer in them. So there's a lot of potential for, better approach here. Folks call me all the time and say, "Hey, I want to put a mixer in my tank. What kind of mixer do I need?" And really the first question I always ask is, well, what's your process goal? Why do you want to mix your tank? Thermal stratification is a really common issue in most tanks where it's hot out. And thermal stratification is something that you've probably experienced yourself because you've taken a dive into a pool on a hot day. There's that really warm layer of water that floats there. And when thermal stratification sets up in a tank and you have that warm layer of water, it's kind of like a rubber raft. So when the water level goes up, it floats up. When the water level goes down, it floats down.
And is that water not mixing?
It's not mixing
because of the temperature difference?
Temperature difference, exactly. And so you can spot a thermally stratified tank in the summertime if you climb up to the top and pop the hatch. It might smell a little bit like a wet dog. You take a flashlight and shine it across the surface of the water. You might see some biofilm floating there. And what essentially happens is this warm layer of water gets trapped in the tank for months at a time sometimes. All the residual comes out of it, and it serves as a reservoir for bacteriological growth. And so, eliminating thermal stratification in your tank is a really important step if you've got anything like low residual levels that are a challenge. For example, if you've got the ability to measure your secondary residual coming into the tank, and you notice that you've got someone that comes in, but when it comes out, there's not as much left, that's a pretty good sign that you've got, bacteriological load in the tank that you should be addressing with a mixer. So thermal stratification can be a reason to mix your tank. I've got lots of customers that want to mix their tank because they don't want any ice to form. So
that's what I was about to ask. Does it work the same in the cold?
Yeah. So thermal stratification is different in the winter, where we really worry about ice formation. And if you have an ice formation in your tank, essentially what can happen is, it's really cold at night. You get a layer of ice that forms, and it goes from one wall to the other. And then in the morning, everybody jumps in the shower, and you get that initial drawdown in the morning, and you can actually draw the water down and have the ice shelf that floats in the air and is suspended inside of your tank. A little bit later in the morning, all of a sudden it gets warm out, sun starts to shine, and that ice shelf can fall and collapse and rip everything off the wall of the tank, rip the ladder off the wall.
To rip coatings off the wall?
Damage coatings, absolutely.
Stuff like that.
Yeah. So again, adding a mixer is a great way to just eliminate ice formation. Mixers don't add heat to the water. All they do is take water that's a little bit warmer from the bottom of the tank and bring it up to the top where it's cold. So as long as we've got about 6 or 8 degrees above freezing, that's enough excess heat usually to stop ice formation. We've got customers across northern Canada into the Arctic, and North Pole, Alaska's got one of our mixers. So this is definitely a product that mixing can be really important in cold climates, no question.
Can you kind of give me the type of mixers and which one you would recommend when?
Yeah. When I first started at PAX, we had one mixer. I think we're up to 26 models right now. So really different approaches for different geometries of tanks. We've developed a whole line of mixers, especially for elevated tanks that have a sloped floor. We have jet mixers. We have mixers where we've got, a pump that's external to the tank and just a set of pipes inside the tank for different types of dosing applications. So really getting into the details on what type of mixer you need. We're going to look at your process goal. We're going to look at the volume of your tank. We're going to look at the geometry of your tank. We're going to look at how much water is moving through your tank. And based on kind of those things, we'll make a recommendation. But lots of different options depending on what we're trying to achieve, what the existing conditions are.
Is there a good guide for engineers or operators to kind of know where to start in that, like so that they can whittle it down a little more for you? Or is it they just come to a manufacturer like yourself and say, hey, help me pick one off?
Both are good. And oftentimes, we do have a guideline based on tank volume for thermal process or thermal destratification. But certainly if it's an engineered project and you've got a consultant who's putting together a specification, we'd like to, get the opportunity to really establish a basis of design and make sure that we're being thorough to pick the right mixer.
Yeah, because you guys do, engineers do a couple projects. You guys just do tons of those projects. You have a lot of value to add when in that spec process.
Yeah, absolutely. And we really genuinely are experts in our area. Just, distribution system water quality is at the very center of what we deal with every day on the sales side of this company. And we want to be, giving people good advice. Building trust is about, giving people the right information to make a decision. That's what we try to do.
All right, cool. Thank you so much for sharing your insights today.
Real pleasure. Thanks for having me.
Yeah.